Of those, which ones do we want to see, go over, have questions about? So, 2 we will do, 3 we will do, 4 we will do. 1 can be done on Desmos, so I'll show you that, and then same with 5. So we'll do the others first. So 2, this is something you have to know. So if you get a question like this, you'll need to know the slope of something that's y equals 3. It's a y equals, not a y and a x, so that's your point up. So what should the slope be? Not x, just m equals 0. Is y and up. M is slope. So m equals 0 is your answer for number 2. Range of this graph, so there should be like a point here, and then it keeps going. Keeps going up. I went like this. So lowest point starts at -2, and then it keeps going up. So it's everything above -2, or y is greater than or equal to -2. Questions on those 2? That would be the same, but they would want it in this format. Lazy.
But last class, for the last one, number 5, you said that it had to be like the greatest.
If there's 2 of them.
So if there's only one,
You would do whichever one it was. So if it went down, you would do less than. If it went up, you would do greater than. But if it's between 2 points, it's always less than or equal to. That's the confusing part. For 4, you have to find your slope and your y-intercept. Those are 2 good points. Y-intercept is at +1. Slope is up 4 to the right 3. So what would that equation be? So that's what that should have been. You could have done the work for 5 or 1. I will also show you how you could use Desmos for those 2. So we'll start with 5, go back to 1. So if you put that into Desmos, you can either graph by intercepts, but this one's a decimal, so maybe not do that. Or find your y-intercept and count your slope, which is 4/2. Yes. We knew that already. It was good. Graph your slope is what I meant. So graph it either way by all the points or your intercepts. The first one, I meant to have this with me. If you wanted to do this in Desmos, you would put the points in. Into 2 separate lines. And then you could count your slope from there, and that would tell you what your slope is. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3/9 to -1/3 should have been your slope. Regina. m equals. Okay. As a reminder, if you are using Desmos, it needs to say use Desmos, that's your word, for when I collect your SharkBite answer sheet. Okay. Questions on SharkBite? Okay. There are a lot of questions on the SOL review, so I'm going to go through them as quickly as possible so we can do our other stuff. So I'm going to show you the work for some of these, and then show you how to do them on Desmos for some of them, and then show you how you can check yourself on some of them. So this looks messy first. So if you want to write down all the work now, you can, but remember this is recorded, you can go back. I would say write down the answer, I'll talk through the work, and then you can go back and rewatch if you need to. So I know we did exponents such a long time ago, but we have to remember our exponent rules. So if we are multiplying something, a power to another power, we multiply that power to everything inside. So both of the exponents change. Then we could figure out what this is. 2 squared is 4. Multiply the 4 and the 4 together to get 16. If we're multiplying like bases, we're adding the exponents. Or subtracting in this case. Our final answer cannot have negative exponents, and that is moved to the bottom. So I'm going to talk through 1 through 7, and then I'm going to show you how you can check these on Desmos. For 2, the actual numbers you would divide, so 15 divided by 3 gives us 5. If we are dividing like bases, we are subtracting the exponents. So negative 5 minus 2, 7 minus a negative 8. Figure out what those would be. Negative 7 and 15. Again, our final answer cannot have negative exponents, so we would put that in the denominator. So 5y to the 15. 15 over x to the 7th is your final answer for 2. For 3, you have to do what's inside the parentheses first. Think of your order of operations. So inside we have like bases. We are dividing, so we are going to subtract the like bases. 3 minus negative 2, 4 minus negative 4, and figure out what those two things would be. Then we still have a power on the outside, so we're going to multiply that to both. And then we can't have negative exponents in our final answer. So those will both get moved to the bottom. So 1 over x to the 5th, y to the 8th is that final answer. For 4, we have like bases, we also have exponents. So take care of the exponent first, multiply that to both of your exponents inside your parentheses. Figure out what 2 to the 4th is, which is 16. Multiply your like bases by adding your exponents, and then that final answer should be 16y to the 7th. Before I talk through 5, 6, and 7, what questions do we have on 1 through 4? Five, kind of same as 3. We have stuff inside the parentheses, so we can divide 30 and 6 to get 5. Subtract your exponents, 5 minus 3 to get 2. Then raise all of that to the second power. So 5 is being raised to the second power. The 2 gets multiplied by 2. And then figure out what 5 squared is. So 25x to the 4th is that final answer. 6, we have to remember that anything raised to the 0 power is 1. So that entire numerator becomes 1. And then we have to move the y up because it was already negative and it can't be negative. So y to the 3rd over 6x to the 4th. And then for 7, you would multiply your exponents first. So negative 2 times negative 3 gives us 6. 5 times negative 1 gives us negative 5. Then we're dividing like bases, so subtract your exponents. In this case, you end up adding, and your final answer becomes a to the 11. What questions do we have on those three? So I'm going to show you how you can do these in Desmos, and you can go back to this recording to try these out on your own if you don't have it up right now. So one, I'm going to show you that I typed in the original expression, but I made the variables capitalized. There's a reason for that. Then I typed in the final answer that I got. It's going to ask you, do you want to add a slider? So if you do that, and you move it, these two numbers should be the same. If they're not, something's wrong. So the slider for x is already there, but because the second one had y, I have to add another slider. Change that value. And these are the same, so that was our final answer. For 3, same thing. The sliders are already there. I have the same number, so I know those are right. Numbers are the same, so I know that's the right answer. This is going to happen for all of these problems. If you had a different variable, you would just have to keep adding the sliders so you can see did you get the correct answer or not. So this is 6. That was the right answer. And then 7 had variable a. So if you use x or y, you have to capitalize them. But if you use a, b, c, d, f, you don't. You can. You don't have to capitalize them, I mean. But it should work the same. So a to the 11 was that answer. 8, you could do the work, but you don't have to do the work. You could put them all in Desmos. So the work will be up here, but I'm going to show you how you could just solve this in Desmos. Basically the same way. You would put in your original, put in each of the 4 options. So just know that D is your answer. And you look, the slider's already in there, or you would have to add the slider. Look and see which one matches. And that should tell you which one is your answer. Questions on 2A before we talk about 2B? Write down the answers. I'm going to show you how we found these answers. So the things in blue are the answers. So for 9, x minus 5. 10, you can write either or, 2x plus 2, or 2 in parentheses, x plus 1. 11, 3x minus 5. 12, 7x plus 5. 13, x minus 3. Anyone still writing 9 through 11? $14, 3x plus 1. 15, 4n plus 1. 16 was C. Now, this is something we haven't talked about yet, but even if you forgot, this is one you could easily put into Desmos and it will solve it for you. I'm going to go through each of these. And I'll come back to you some of this. So if you graph the original, it's going to give you a line. Whatever that line is your answer. So if you know how to find your slope and y-intercept of this line, so y-intercept is -5, slope is 1, x minus 5. We'll talk about the y later. Same thing, put in the original, and we get slope of 2, y-intercept of 2x plus 2. $11, y-intercept is at -5, slope is at 3, so 3x minus 5. $12, y-intercept is at -3, slope is 1, so x minus 3. $14, y-intercept is at 1, slope is 4, 1, 2, 3, so 3x plus 1. $15, same thing, even though it had less. This one had ends. You cannot put the ends into Desmos, so it won't work. You'll have to make them x's. One, and then the slope is 4, so 4x plus 1. Yes, it is. So 17 was your multiple choice one, if I'm not mistaken. Unless I didn't mean that correctly. Oh, that's not the one. Okay. This one was multiple choice, but I chose the one now. So with this one, because it gave you options, whichever line overlaps the one that the original is on, that would be your answer. So if I didn't have that, that would be, the black would be the original, the orange is that. Questions on 2B? And then on 2C, some of these can be done in Desmos, some of them you have to know, so I'm going to talk through some of them. So for this first one, I put in the original. So I'm going to show you this first, and then we'll talk through it. Not that one. That one. So the original is in red. It's thick. There's a lot of stuff going on. I put in all of the answer choices except for the numbers that were by themselves. If this is squared, our answer can't be squared, so we can get rid of those. They're a little trickier. So that takes care of some of them. Then we're looking for which of the other lines go through the red ones at the x-axis. Which ones do that?
The blue one and the black one.
So those two, 2x minus 3, 2x plus 3, would be some of your answers. I say some because there's one that you wouldn't be able to do unless you did the work for. When you get into factoring, we can divide these both by 2. That's why 2 is also an answer. If that doesn't make sense right now, that's okay. You can go ahead and write down 18a through c. So the factors are x minus 1 in parentheses and x minus 3 in parentheses. The x and y intercepts you could find, because we've talked about that before. Figure out where it crosses the x-axis and the y-axis. Domain and range we could also talk about. So some of this notation will not look familiar, but we're going to talk about that. So domain is all real numbers. Range is y is greater than or equal to negative 1. So these things you would have to know how to find, because it doesn't give you like an equation you can put in. Questions on 17 or 18? Let me show you the answers for 19, 20, and 21, and then I'll go back and show you how to find them. So A, C, D. Same as the first one, if you put in the original and put in these answer choices, it will help you find your answer. So the black one is the one we're looking that it goes through, and we're looking for which of the lines given go through the black line, but at the x-axis, and there's only one of them. And it would be that red line. Same thing. So which of these lines go through the black, and the other one is like way out here. So the only one that crosses through the black line at the x-axis is the green one. And then, even though this format is weird, you can put each of the answer choices in and see which one goes through those 2 points. It said your solutions were 2 and 6. So if you plot those 2 points and see which of these go through it, I think it was the first one. So that will tell you that's your answer. Questions on any of those last ones? The SOL that's due next week, next Friday, is A3. So all of A3. Make sure you guys are practicing this. It's good practice. The SOL will be here before we know it. I don't know those dates yet. When I know it, you'll know it. Regina? Say that one more time. Hold on to this. Make sure you don't lose this. Make sure you're working in this. Come see me if you have questions. Refer back to your notes, because I know we did radicals such a long time ago. What are our next ones? A3. Just do your next Friday. Just A3. Just A3. Because there's a lot. So I try to make it so that it's about the same amount each time. Right. And then everyone should have these notes out in front of them. So this will be calculator, as will the next 2. I'm going to have you write down the definition and the steps. while you're writing that down, I'm going to read it. So the substitution method, our next method of solving systems, is a method by substituting equations within one another. This will look somewhat familiar because we kind of did this already. And then the steps: solve one equation for x or y. Substitute this expression into the equation and solve for the variable. Substitute your answer into the other equation from step 1 and solve for the other variable. So it's a lot of solve, substitute, solve, substitute. Solve, substitute, solve, substitute, solve. My plan is to do 5 of these, and then you'll have time to practice. Any of you guys want to see anything else? Okay. I know it's between the... So just wrote this on everybody. I know all SOLs are between the 12th and the 20th. I don't know when the math SOL is yet. They didn't pull this up. Anyone still writing? So let's start with this first example. When we are solving by substitution, we need 2 equations. We have that. One of them needs to be solved for x or y in order for this to work. If it's not solved for x or y, we would have to solve it first. If they're both solved for y, it works a little different. So these are already solved for y, so we don't have to do that part. We do have to substitute one of the equations into the other. It doesn't matter which one because they're going to be the same. So you can either take this part and substitute it in for y here, or you can do the opposite and take this equation and substitute it in for y here. However you do that, you're still going to get one equation that looks something like 2x minus 5 equals 4x minus 1. Because we took what y equaled for one of them and put it in for where y was on the other one. And since they are both equal to y, we can set them equal to each other. This is a problem we've seen before. We can solve this. So what would I do? Okay. Remember, with these, you can do them one at a time or at the same time. So if we move 2x over here, we have to add 1. So we have -4 equals 2x. And divide both sides by 2. But that's only part of it. We found x, we still have to find y. You have 2 options to find y. You can either put -2 into the first equation where x is, or put it into the second one. It does not matter. You should get the same thing either way. So let's say I put it into the first one. Then you would solve for y. -9. The last thing we have to do is put this as an ordered pair. As we were talking about last class, the only 3 types of solutions are 1, an ordered pair, none because of parallel lines, or infinitely many. So our answer would be -2, -9. What questions do we have so far? And number 2, do we have an equation that solve for x or for y? Yes. The first one? So this is like a rare case where this happens. Usually they'll look something like these. So we're going to take this part of the equation and put it in for y, where y is, use parentheses. So we're going to rewrite this so that it has the 6x. You may vaguely remember doing this when we were doing word problems / solving before. Then we would just solve it. Combine your like terms and divide both sides by 2. So x equals what value? Then again, you have 2 choices. You can put it into the first one. That's the one I would recommend because it's already solved for y. You could put it into the second one, but then you have to solve more. I feel like do a little bit more work. So y equals 6 times -1. What's our y value? Nope. It is negative. What's our final answer? Questions so far? Three is the same, the equation's just a little longer. So we have an equation that solves for y. Where would I put this? Say it again. Where y is in the second one. Rewrite that one. So 3x plus 8 times, in parentheses, x plus 9 equals -5. Then keep solving. You have plus 8x plus 72 equals -5. What would we do next? Okay. So that would give us 11x plus 72 equals -5. And then what? So 11x equals -77. Divide both sides by 11. What's x? -7, so yes. What do we do with that -7? Okay. And you can put it in both, it doesn't matter. Put it in either or, I should say. What's our y value? 2. So our ordered pair is what? Questions so far? Number 4, do we have an equation that solves for x or for y? Yeah. Which one? The first one solve for x. It's not solve for y, but that's okay. As long as it's solved for one of them. So then, where would I put this? Where? So, depending on what's already solved or what you end up solving for, you have to make sure you put it in the right place. If you put it in the wrong place, you're going to still have two variables, and you need to have just one as you're solving. So 8y plus 14 minus 6y equals 12. Combine your like terms to get 2y plus 14. Get rid of 14. And divide both sides by 2. Then just like before, we solve for y this time, so we're going to put that back in. Here. The arrows, you don't need to do them, but if they help you see where they're supposed to go, you can do that. So it's going to be x equals 4 times negative 1 plus 7. What's our x value going to be?
X is equal to negative 4 plus 7.
Which is?
So it's going to be 3.
So even though we solve for x second, it still needs to come first. What questions do we have so far? So all the examples we've had so far have been x or y already solved. We're going to do an example where x or y is not solved. So we'll do 5 on the back. First, let me say that you have choices. You can choose to solve for whatever you want. However, depending on what you choose, you may end up with a lot of fractions, and then you'll be substituting in a lot of fractions. It'll get messy. I would recommend looking for the variable that's either has a coefficient of 1 or negative 1. That would be the easiest thing to solve for. If I were solving for y, what would I do? How would I get y by itself? Whether you put it minus 2x minus 2 or minus 2 minus 2x doesn't matter. Because it's going to work itself out either way. Then you have an equation that solves for y and the process is the same. You take this and put it into this y. 5x plus 3 times negative 2x minus 2 equals negative 8. So this would be minus 6x minus 6. This would give us negative x minus 6. Add 6 to both sides. And divide both sides by negative 2. Then, when you go to put it back in, you have different options. You can either put it into the original, or the other one, or you can put it into the solved one. That would be my go-to, because it would be less work. So what would your y value be? So then your ordered pair would be 2, negative 6. I want to say at least one of the following examples, the rest of the examples will give you no solution, the other one will give you infinitely many. What will happen is, as you're trying to, when you go to substitute and you combine your like terms, the variables disappear. You'll know really quickly that you have no solution or infinitely many solutions. But looking at the remaining ones, which ones do you want to see, go over, have questions about? If you want me to find which one has the no solution or infinitely many, I can find one of those. Do you have any other questions? Anything you want to see, go over? Not for the remainder of class, you can work through these practice problems. You can try the one Khan Academy on this that's due next week, so you don't have to worry about it. And then after you've done that, then you can work on other things. Let me know if you need my help, have questions.